He said it's Mike Galloy. He's the guy who takes the raw data and turns it into stuff that we all can use.
No.
Yeah, so yep, I'm Mike Galloy and I'm a software developer. So if you have any science questions, feel free to ask other people about those. I'm going to give two talks here. One is a very quick look at the data files and how to get them, things like that. And then maybe a little bit more detailed talk about the calibration processing and the steps that are involved in that. And then this afternoon, we'll have a practicum that involves actually getting your hands dirty with the data and opening them up, looking at the files and doing what things that you want to do with them.
Yeah, well, we should have mentioned, the way this is set up is in the mornings, we have talks from you all and tutorials. But in the afternoons, we have real hands-on, grab some data and do something with it. So that's the way the workshop has been set up. Go ahead.
No problem. And also feel free to interrupt me if you have questions as well. Right? I intend to be interactive. Getting the data. In general, you go to our website, which is listed on that slide there. Right now, it's preview data, which is only quick look data, right? So it's just images right now from the website. That will change to FITS files shortly. But for us here, we'll be giving out, our FTP site will be giving out actual FITS files so that we can do our exercises. And if you want to look at specific data, then we'll have that. You can also always contact us for special requests for data if there's data that we are currently not publishing or something. We have quality controls in place, and sometimes you might be interested in data that doesn't pass the quality, right? To see if you can get something out of that. Or in any case, if you have data that you don't see on the website, please contact us. At the end of the presentation, I'll have you show you mechanisms for doing that. But please contact us if you can't find what you're looking for. Okay, so basically the processing produces level 1 products and level 2 products. And level 1 products are Stokes just IQUV for every wavelength. And so if you used COMP before, then these are organized in a little bit different way, because for COMP, you might only have particular Stokes parameters for a given file, right? You might have only I and V, or you might have IQU or IQV. Whereas in UCoMP, you always have all 4 Stokes parameters, right? So, but the other thing is that if you've used COMP data, you'll know that the data comes in extensions, and that's the same for UCoMP data, is that you have a FITS file with multiple extensions, right? So you'll have one extension per wavelength that's measured. So we have 3 points across the line in 1074 here in this example at the bottom. So there's 3 different extensions, one for each of those wavelengths, and then there's a background continuum that you're subtracting in each of those same wavelengths, right? So you get a total of this 3 points across the line gives you 6 extensions. The file name, I should probably help you code this file name here. You have the date, a date and time in UT. That's also somewhat of a change from well, I guess the published comp was in UT. So this is UT time and date and time. We'll always have UComp. And yes, we'll make those available.
Yeah.
We'll always have UComp in the name of the file. And then the wave region, so 1074 in this case, and then L1 or L2. So this is an L1 product, IQUV. Then we put the number of points across the line, 3 in the file control interface. Okay. Okay. So next one, FIT files have headers. There are a bunch. I think I checked yesterday and saw that there's 179 different FIT headers, all kinds of different information in there. Some of them you'll be more interested in than others, probably. And we can better look at these in the practicum, you can kind of scroll through there and see what's there and ask questions about what things are and stuff. The first 5 or 6 categories here, you're probably fairly interested in. There's the required FIPS keywords, right, telling you how big the image is, such, and then the basic information about like the date time of the observation. The filter is a useful one that tells you what wave region we're talking about. So 1074, for example.
You have a question.
Oh, where is the question?
Go ahead.
Okay, go ahead.
Hi, I want to ask about the background extension. Like, what did the background extension contains? Like, level 1
Where,
data.
yeah, where do they come from?
Yes, what does it contains? Like, you have written like in level 1 data there are 6 extension. 3 contains the tunings data and 3 are the background extension. So can you?
Yeah, we'll talk more about that in the second talk about the exact process. But basically, Steve mentioned there's a on-band and off-band, camera each measurement, and you're measuring that background every time, and so you just keep track of those per wavelength, and then we output that value into one of those extensions. The WCS information, like orienting this image in space for us, it tells you the plate scale and how large the pixels are and where 0, 0 is and stuff. Ephemeris information, mostly this is just a convenience, but it's very nice to have things like the B angle and P angle and various information about sun and time. There's level 1 processing information, which it has a version in it, and that in a date. So if you've given a level 1 file, you'll know when it was processed and what version of the code, because the code does change, and we update and reprocess the data occasionally, and so you'll be able to tell what version of the code processed the file that you have. And then there's some quality metrics that we'll talk about more when we talk about measuring the quality. There's a couple quality processes that we do for the data. And so some of the metrics that we use to do that are actually in the file. And so you'll be able to see if this file barely skimmed past the quality or it was very good image. And then a bunch of stuff that mostly I think we're interested in. If you haven't used FIPS files with extensions before, like if you haven't used comp data, for example, it's a little bit, you just have to use an extension, right? You have to tell it what extension you are. You have to have a way to know what extension is. So for instance, I'm pulling from 0 in this first FIPS read. Okay, in the first FIPS read, I'm pulling from the primary header, which has no data. Like it has basically, because you can't have no data, it has like 0 as a scalar, as the data in the primary header, and everything else in the extensions. But the primary header has a lot of information. So you probably want the primary header, and then you want the extensions that you're interested in. So extension number 0 is always the primary header, and then you have to have a way to know what these extensions are in your file, right? And if you know from the file name 3 points, well, then you'll know what's happening here, right? Center wavelength is always going to be extension 2. Then. And so that's how I knew in the second FIPS read to pull out extension number 2 to get to the center line. And that array is an IQUV, right? So it's an X size of 1280 pixels, a Y size of 1024 pixels, and then 4 is the IQUV. So I is 0, then QUV. That primary header, very handy. Here I just pull out for one example. We'll have more interactive stuff with pulling out all kinds of different things in here, but I'm just pulling out the date time of the observation. Right there it is. It matches the file name. There's also a FIPS header from each extension, right? It doesn't have a lot that you'd be interested in, but it does have the wavelength, right? Which is is super important, right? Because that varies by extension. Everything that doesn't vary by extension, we're trying to put into the primary header. I'll have a couple ways to give feedback at the end of this presentation, but if there's things that would be convenient for you to know, or that you think you need to know for your science, that should be in these headers, please let me know. We can add things there. We've tried to organize them so that, and we'll see, check out the whole thing, kind of in sections. So hopefully it makes it a little bit easier to find what you're looking for. Here is just a very basic display of readings of files and then using IDL commands only, right? So nothing fancy at all. Just displaying the center line. I index it by 0 to get I hit it with a power of 0.7 and a min max 0 to 40. So that power of 0.7 gives me that display of intensity there. This is for a 1074 file. And then I display linear polarization using a log. And I don't think I didn't, I had calculated this linear polarization, but it's just the square root of the Q squared plus the U squared, right? Just the other indexes of that center line, the 1 and 2 indices, and displaying it from -2 to -0.3. We'll have better displays later. We really want averages for this. This is for a single file for linear polarization, so that can get a little rough. Right now, there's one flavor of level 1 data, basically IQUV. For the level 2, there's several different flavors of FITS files. So there's a dynamics, so-called dynamics files that are intensity based, right? And they have a peak intensity from this so-called Gaussian fit, which we'll talk more about later as well. An enhanced intensity, which is a image processing technique to bring out the contrast, right? So if you want to see structures, you might be able to see it better in the enhanced intensity. And then a Doppler velocity in line with found from that Gaussian fit as well. Okay, so all intensity based. There's dynamics files. Well, one thing that you might ask us for is that we produce all of these files for every wave region, but and for dynamics, for the 5 wave regions that we're publishing data for, we always give you the dynamics files, or at least the ones that we've deemed good. We always give you the dynamics files. For the polarization, that's down to just 1074, right? We only give out polarization on the website. We only do 1074. And this has some other things in it. It still has an intensity, but this intensity is a summed intensity. So it's the 3 middle wavelengths divided by 2. Okay? Comp had a similar scheme, but calculated in a slightly different way. And then an enhanced intensity, that same enhanced intensity algorithm that we used in the dynamics file applied to the sum intensity. But this is a polarization file, so it also has a Q and a U and a linear polarization. And then also azimuths and radial azimuths, like you saw in Steve's. So those dynamics and polarization files correspond to a level 1 file. You get one level 1 file produces 1 dynamics file, 1 polarization file. The next 2 are averages of good files. So we have a step where we find out the good files of a given program, and program here means same wave region, same observing plan right now. So we'll talk about this as well in more detail. And I think Ben will talk about this a lot. For 1074, we have the so-called waves program and a synoptic program. So those are averaged separately in the, so you'll get a waves average and a synoptic average. And for 1074, everybody else basically just gets a synoptic average. But they look exactly like a level 1 file, just reporting IQUV with their extensions, but They're an average of from 1074, it could be over 100 files could be averaged together from an hour period. And then the kind of higher order processing is the quick invert file. Corresponding to every mean or median file is a quick invert file that calculates the things that we had earlier on in the dynamics and polarization, right? So you'll have a thumb intensity, you'll have your Q and U average, but then you'll have linear polarization, azimuth, radial azimuth, and then from the dynamics, you'll have Doppler velocity and line width. But these are all, I mean, the quick invert file, I think that's the one that Forward typically wants to use a lot. I mean, and it gives you a nice summary of a day. If you're not looking at dynamic features, it gives you a nice images to look for each day. And that's it for this first look. So I'm going to go into more detail in the second talk about what's actually happening to do all those things. But I do want to stop and give you contact information here for myself. MLSO data request is a nice email to have because it goes to a bunch of people. Of course, I mean, you guys here probably should be going to Steve for everything. But also take a look at our GitHub repo. Right, all the code for the pipeline is open source. Look at it if you want to. Feel free to create issues, right? If you're interested in some particular thing, you just email me or whatever. Or if you're really into GitHub, you like to do that kind of thing, feel free to mess around there. Are there questions about that before I move on to the next talk, which has got more details about the pipeline steps?
So I think Cheryl asked me to make multiple recordings.